Hello everyone, thank you for joining my tutorials. Today we'll learn how to calculate the Euclidean distance. So what does it mean by Euclidean distance? So Euclidean distance is the output raster, contains the major distance from every cells to the nearest cells. The distance are measured as a crow flies, that is a Euclidean distance in the projection unit. So we must have our shapefile or whatever the data in a projected format. Then only we can able to calculate the Euclidean distance to the raster. So such as a feet or a meter. Okay, and are computed for cell center to the cell center. So where it is useful? So the Euclidean distance tool is used frequently as a standalone tool for applications such as the finding the nearest hospital for an emergency helicopter flight. If we require an shortest route, for that we can use this Euclidean distance, or alternatively the tool can be used where to create a suitability map. So for the suitability map also, this are very helpful when data representing the distance from a certain object is needed. So this is very helpful. So we'll learn how to prepare this Euclidean distance map. So for that we have a data source. I have this data source, like I have the shapefile of this study area. Then I have road shapefile, and also I have this settlement point. So what we need to do first, we'll use this point source. So these are the village point source where I will use to find out the Euclidean distance for this point. Okay, so what we can able to do first, we need to project this first file. So my file is already projected. If we'll go to properties, we can check here that my file is already projected. This is a Lambert conical projection I have used, Lambert conform conical. So this is already projected. So to calculate the distance, what we need to do first, we'll go to the art toolbox. In the art toolbox, there is a spatial analysis tool. Okay, in the spatial analysis tool, there is a distance, and in the distance there is a Euclidean distance. So just click on Euclidean distance, and here I will take input raster or feature source. Okay, so first I will take, suppose this is my settlement area and I'm interested to prepare the Euclidean distance for this village settlement. Okay, village settlement Euclidean distance I will calculate first, and then we'll calculate the road. So output raster means where I want to save. So let me save in a folder where I have created one folder. In that folder I will save this, that is a settlement EU Euclidean distance. So just click on save, and now all things will keep optional. Just we need to provide this projected shapefile in environment that will get the Euclidean distance as equal to this our shapefile. So just go to environment, set the processing extent as the same as this projected Jalna shapefile. Also we'll mask this. So in the raster analysis, just we need to click here on the projected Jalna, just click on OK, and just click on OK. So this way what we need to do, we'll calculating the Euclidean distance for this point source. So now we have got these values. So this point, this color indicating that, let me try this in the 5 color, reclassify this into 5 colors. So these are the village settlement. So from this village settlement, we can able to see this yellow color is here, which is indicating that they are the further closest distance. And as we are going further away from this color, from this point source, as we are going further away, the distance is increases. So this distance showing in meter actually. Okay, so what we need to do now, we'll reclassify this. We'll reclassify this. So to do reclassification, we can reclassify this into 5 classes. Just go to spatial analysis tool. In the spatial analysis tool, there is a reclass and reclassify. So now we can reclassify this from this point source, or from this we can calculate this into 5 different categories. Okay, so just click here in the U settlement. So here we can classify this into 5 classes. Okay, suppose if we are using for the suitability analysis, so hospital suitability analysis, so the closest service facility from the village point will be, we can provide a highest weightage. So suppose if you are going to prepare some village suitability and where you are providing a 5 for the highest suitability, so you can provide a, this is the closest service facility, we can provide a 5. So this is further away, we'll provide a 4. So 3, 2, 1, like this we can able to prepare, we can give ranking to this. So after that we can click on the reclass, village.tif, and just click on OK. So now you can able to see we have reclassified this. This 2 points are still left. We can again reclassify this, no problem. But this way you can able to calculate the Euclidean distance from this point data. And suppose we are interested to calculate the Euclidean distance for the road data set. Okay, I have this road data set and I'm interested to calculate the Euclidean distance from this road data. So what we can able to do, we can again go to the Euclidean distance in the spatial analysis tool, distance, then Euclidean distance. So input raster, again I will take a road, this time we're calculating for the road. So road EU, that is Euclidean distance, and just go to environments, processing extent, same as our projected Jalna, and we'll use mask here. So analysis tool, so just select road PRG Jalna, okay, and just click on OK. So now we are calculating Euclidean distance for this road. So as we are able to see here, then this distance, this color indicating that this is from 0 to 202 meter distance is there. So similar way, everywhere we can able to reclassify this also as the same process. So same process, if you want to reclassify this, so we can 5 classes, apply, okay. So now to reclassify this, just go to reclass tool and just take this road EU, and now suppose the nearest hospital distance you want to give highest weightage. So similar way as we have given village, so here also we can provide a similar weightage the way we have provided. So suppose you are giving 5 to the closest service facilities, so that thing also you can able to do 5, 4, 3, 2, 1, like this, and provide the output raster and just click on OK. Now here also you can able to see we have reclassified this. So this way we can able to calculate the Euclidean distance very easily. So thank you.